Okay, our topic is trigonometry. Our subtopic is bearings. Bearings is used to show direction, and mostly the captain of the boat or the ship and pilot, person who fly plane, normally use bearings. Because let's say, for example, a pilot that needs to fly a plane from Guyana to Trinidad. We know that in the sky they don't have any road, right? So you need to travel, and the sky is very big. So let's say if you just fly the plane just like that, you would lose because you would not know what direction or where to go. So you need to travel at a certain bearing or at a certain angle. So let's say probably you might have to start off traveling at 65 degrees in order to reach at Trinidad. That's just an example. Or let's say you're in the sea, the captain, and probably in the middle of Atlantic Ocean. You need to use bearings in order to travel to different ports. Let's say if you are sailing from Guyana to Barbados, the captain needs to use bearing. However, the captain do not need to use a pen and paper in order to calculate the bearing because the ship are computerized. But before the programmer can install those bearings on the ship or the airplane, they had to know bearings in order to do so. So in this lesson we'll focus on bearing. To this lesson we'll just focus on the introduction to bearing. So bearings is used to show direction, and we know the four main direction is what? North. These are the four main cardinal points: north, east, south, and west. Good. So those are the four main cardinal points. Also bearings, it starts from the north line, so it always starts from the north in a clockwise direction. So from the north in this direction, the way the clock hand goes. This is a way to write bearings. It is written in 3 digits. So let's say, for example, you want to write the bearing. Bearing is represented by angle or degrees. Good. So let's say if you want to represent the bearing 60 degrees, well, we know that the number 6, they only have 2 digits, so we add a 0 in front in order to make it 3 digits. So we represent bearing using 3 digits. If you want to represent 4 degrees, we put 004. And here we have 160. Well, 160 already have 3 digits, so we don't need to put anything in front in order to make it 3. Alright, so the north is taken to be 0 degrees or 360 degrees. Right? That's what the north is taken to be. The east, okay, so north, if you look at this, there's a right angle will be formed there. So east will be 90 degrees. So what I'll do, I'll write 90 degrees here. Good, 3 digits. South, well, this is a straight line, right? And you will know that a straight line is made up of 180 degrees, so this will be 180 degrees. Okay, so you're basically adding 90. So we have 90 there, plus another 90 will give us 180, plus another 90. 180 plus 90 will give us 270. So west will be 270 degrees. Good, so these are the 4 basic. Between north and east, we call this northeast. And since here is 90 degrees, this should be 45 degrees, half out of 90. So here we'll add another 45. So if we add 45 to 90, that will give us what? 135. 135 degrees. And since here is east and south, we don't say east-south, right? We say southeast. So here will be southeast. Here will be southwest. Good. So what I'll do, I'll add another 45 to 180. So 180 plus 45, that will give us 225. Southwest will be 225 degrees. Good. So here we'll get northwest. Northwest. Right. Good. So northwest, therefore, will be 270 plus 45. That will give us 315 degrees. That's northwest. Okay, so what I'll do now, in bearings we don't need to use protractor. Here's our first example. Use diagrams to represent the following bearings. Part A, so we have 4 examples. We'll go through all 4. So the first thing, whenever we want to represent bearing, we need to draw a north line. Alright, so the bearing of B from A means that we start at A and then we are going to B. It's 40 degrees. So the first thing I'll do now, I'll draw a north line. Let me see, we should use a ruler, but let me see if I can draw it without using a ruler. Good, so this is our north line. The north line should always be perpendicular. Good, so the bearing of B from A is 40 degrees. Alright, looking at our diagram, we know that this here is 45 degrees. So 40 degrees will be a little above here. We don't have to be accurate, so we just make a good sketch of it, or a good estimation of it. So let's say 40 degrees might around here. This can be about 40 degrees. Good, so the bearing of B from A, so we start at the point A. Here's our starting point and we end here. It doesn't matter how long you want to draw this line. This line can be from here to there, or it can be about that width or even longer. And the bearing start from the north line in a clockwise direction, so it comes in this way. So here, and then I will put 0, 40 degrees. Good, so the diagram is as simple as that. Let's say if you do not remember anything, the first thing that you should do is draw your north line. So without reading this question, what I'll do, I'll just draw a north line. And ensure that you use a ruler to draw the north line. Okay, so the bearing of Q from P. So we are starting at the point P. From P means that we are starting from P. Is 65 degrees. Let us look. We'll use this diagram to guide us. Again, we do not use protractor. So here is 45, therefore 65, and here is 90. 65 will be within this range. So let's say 65 is about here. You don't have to be accurate. If somebody put it here and somebody put it there, that's fine. So let me just make a quick sketch of it. Good, so here will be Q. So we start at the north line in a clockwise direction. If we go that way, that will be anti-clockwise or counterclockwise. Good, and this is 0, 65 degrees. Good, so we finished with 2 diagrams. Alright, let us look at the third example. The bearing of L from K. So again, I'll just draw my north line. Here's my north line. You use the letter N to represent. That's our north line. So the bearing of L from K. So we starting at the point K. So here is the point K. It's 150 degrees. Let us look at our diagram. Good. So here is 90, 135, 180. So 150 will be within this range, right? So it's very close to a straight line. So it's around here. So let's see. Good. So here will be L. And we start from the north line in a clockwise direction. If you like, you can label the 150 degrees inside, or you can label it outside. It doesn't matter. So this is 150 degrees. Alright, next question. The bearing of C from D is 225 degrees. The first thing I'll do, draw my north line. So the bearing of C from D, okay, so we are starting at the point D now, is 225 degrees. Let us look at our diagram. Okay, it's how much? 225? Okay, 225 is here, so that's southwest. So from the north line, we'll draw a line like that. So that will be 225. And we label this point C. And we do not represent it like that because that's anti-clockwise. So we need to start from the north line in a clockwise direction. Okay, I'll write it here, 225 degrees. Good, so this is our first example. In another video, we'll do the second example.